Good morning, students. So today we are going to start a new chapter. The chapter name going to be your electrochemistry. So electro means electro. The word electro means it is your electrical energy. Electrical energy. Chemistry is nothing but it is dealing with your reactions. So chemical reactions. Chemical reactions. These chemical reactions liberate heat as a form of chemical energy. So this is your chemical reactions which liberate chemical energy. Chemical energy. This electrical energy can be interconverted into your chemical energy, as well as utilizing chemical energy you can do your electrical energy. So it is an interconvertible thing. That is, using electrical energy you can conduct some chemical energy, that is chemical reactions. Using chemical energy, that is the heat liberated, you can produce your electricity. This interconversion of these two types of energies, that is your electrical energy as well as your chemical energy, can be done through a setup called as cell. It can be done through a setup called as cell. So the study of these interconversion of electrical energy into chemical energy as well as chemical energy into electrical energy with a setup called as cell is called as your electrochemistry. That is, you are utilizing electrical energy to make some reactions, and through some reactions you are producing some electrical energy through a cell. So that is called as your electrochemistry. Now coming back to what is a cell? Very simple. A cell is a setup of three things, that is an anode, a cathode as well as an electrolyte. So it is a setup of three components, that is an anode, a cathode and an electrolyte. This setup, that is the cell, facilitates to convert your electrical energy into chemical energy as well as chemical energy into your electrical energy. So with respect to this cell, there are two types of cells. So this setup can be of two types of setup. The first one is your electrochemical cell. Electrochemical cell. The other one is your electrolytic cell. Electrolytic cell. So now let us see what is this electrochemical cell, what does it do, and what is this electrolytic cell and what does it do. That is, which converts your electrical energy into chemical energy and which converts your chemical energy into electrical energy. First, coming to your electrochemical cell. So electrochemical cell converts your chemical energy into electrical energy. So electrochemical cell converts your chemical energy into electrical energy. While electrolytic cell converts your electrical energy into chemical energy. So this is your chemical energy to electrical energy. So electrochemical cell converts your chemical energy into electrical energy, while electrolytic cell converts your electrical energy to chemical energy. The setup is one and the same. It has an anode, it has a cathode as well as an electrolyte, but the conversion of type of energy is different for these two types of cells. So now coming to what type of reaction is happening in your electrochemical cell and what type of reaction is happening in your electrolytic cell. So electrochemical cells have your redox reaction. Both the type have redox reactions. Both the thing, that is your electrochemical cell as well as your electrolytic cell, they undergo both, that is the reaction in both the cells are your redox reaction, but this electrochemical cell has a spontaneous redox reaction while this electrolytic cell has a non-spontaneous redox reaction. So this is your spontaneous reaction. Spontaneous reaction. So both electrochemical cell and electrolytic cell have some chemical reaction. So what type of chemical reaction if we see? It's your redox reaction. So the redox reaction is happening in both the type of cells. So what is redox reaction? Very simple, you know, it's a combination of reduction and oxidation. That is, a single reaction has a simultaneous reduction and oxidation. So reduction is addition of electrons while oxidation is removal of electrons. The combination of both the things are called as redox reactions. The difference comes here is whether this redox reaction is spontaneous or non-spontaneous. So if the redox reaction is spontaneous, what do you mean by spontaneous reaction? The reaction which happens by itself, it doesn't require any external aid. Such reactions takes place in your electrochemical cell. That is, a spontaneous redox reaction happens by itself to produce some energy, the chemical energy which is being converted into electrical energy through a suitable setup which is called as your cell. Such cells are called as electrochemical cells. So what are electrochemical cells? Summarizing it, it's a cell, a setup which has a redox reaction happening in it, which is spontaneous in nature, which produces some energy which is converted into electrical energy. And we can also see that delta G, that is your change in Gibbs free energy for your spontaneous reactions is equal to negative. Such redox reactions are happening in this electrochemical cells. In your electrolytic cells, again it is a redox reaction happening, but it is a non-spontaneous reaction. So what do you mean by non-spontaneous reaction? The reaction which doesn't happen by itself, it requires some external aid. It may be some heat or electrical energy for the reaction to happen. So non-spontaneous reactions takes place in your electrolytic cell. Since it is a non-spontaneous reaction, you have to supply some electrical energy to make this reaction happen. That is, you are providing some electrical energy to make the reaction happen. That is, to produce the chemical energy from your electrical energy. So for non-spontaneous reaction, delta G is positive. That is, the change in Gibbs free energy is positive. So electrolytic cell, summarizing it, electrolytic cell, it is nothing but it is a cell, that is a setup with a redox reaction which is non-spontaneous in nature. So you are providing some electrical energy to make this reaction happen. That is, you are converting your electrical energy into chemical energy. That is, you are converting, that is, you are using your electrical energy to make some non-spontaneous chemical reaction happen. Such type of cells are called as electrolytic cells. So this is about your electrochemistry, wherein you have to study about both the sections, that is electrochemical cells as well as electrolytic cells. The next thing is, what is the importance of this chapter? That is, why electrochemistry should be studied in your second PUC. That is the importance. The first importance coming to be, that is, it should be having some application in your daily life. As a result, you have been studying this chapter in your second PUC. So what is the application or importance of electrochemistry in your day-to-day life? The first importance is going to be, it is helpful in extraction of many elements. So many elements like sodium by Kastner-Kellner cell, aluminium by Hall-Herold's process, etc. Even copper, purification of copper, etc. can be done by applying this electrochemical concept. So extraction, many elements like this sodium, aluminium, copper, etc. is being extracted or purified using this electrochemical concept. The second major importance of this chapter will be your daily life application of your batteries, that is your car batteries, your scooter batteries, as well as your cells in your wall clocks, as well as your hand, that is your wrist watches, all come under this electrochemical concept. So batteries, cells, etc. have a major application in your day-to-day life. It may be your camera, it may be your wall clock, it may be your wrist watches or your car batteries, all come under the concept of electrochemistry. Even your nerve signals, that is the signaling of the nerve cells to your brain, is again having a concept of electrochemistry in it. So nerve signaling signals are even passed to brain through this concept, that is, it is the passage of this signals is also based on this electrochemical concept. Finally, it is also used in production of many compounds. Production, that is preparation of many compounds like sodium hydroxide, your Kastner-Kellner cell, wherein you are hydrolyzing your aqueous NaCl to produce sodium hydroxide, your hydrogen gas, production of hydrogen gas, your chlorine gas, etc. The production is also having an application of this electrochemical concept. So, all these importance makes this chapter very important to be studied in your second PUC.